วัสดีครับสวัสดีครับกรชนกนะครับกรชนกที่ OBS1 ครับเห็นแล้วครับโอเคโอเค test 1 2 3เรียบร้อยครับon this side where is that? It's the lecture E211, complex plane analytic function. Right. ยังไม่เสร็จดีเลยครับ complex plane complex function function and analytic function. Okay. analytic function. Oh yeah, 52. Or 53. Okay, no, there's nothing more. Yeah, compress it. To 6 and to iPad. To iPad. To iPad. What the problem? We send it to hey, what happened? Oh, 102 megabyte. Wait, just copy this to EE211. Wait, lecture EE211. Yes, sir. Okay, you just use that. Okay. From. Okay, sorry. Anyone else? มีใครจะเข้าที่ซูมีไหมครับบ่ายโมงแล้วนะครับก็ครับกับสวัสดีทุกท่านครับมีคน2คนที่OBS number 1 2 people 2คนเดียวนะโอเคgood afternoon everyone welcome you to EE211 right which is the mathematical mathematics for engineering 2 and we are at the last problem ถ้าไม่มีใครนะครับ I'm not sure this is the last version I hope so okay this is the last version and then we will continue to the next to the จะไม่แน่ใจแป๊บนะครับเพื่อนได้มอค่ะเลยเดี๋ยวให้เพื่อนดูย้อนหลังอ๋อได้ครับแล้วแต่ครับมี2คนครับโอเคผมดูที่ซูมแล้วไม่มีคนจะเข้าครับก็แล้วแต่นะครับผมอัดไว้ให้4ช่องทางเหมือนเดิมนะครับคุณอยากดูเวอร์ชันไหนครับหวังว่าอินเทอร์เน็ตไม่มีอะไรกวนครับจะได้อัดให้คุณแบบสมูทครับเพราะว่าผมไม่ได้อัดเป็นคลิปวิดีโอนะผมไลฟ์สตรีมไปเลยนะนึกว่าจะมีคนดูไปเลยครับเห็นแล้วนะครับของทีเบนครับที่พิมพ์มาครับโอเคทำงานอะไรไม่มีปัญหาครับก็this is the 15 lecture เป็นครั้งที่15นะครับก็หลังจากนี้ก็จะไม่เช็คชื่อแล้วเพราะว่าเกิน15แล้วครับส่วนวันพฤหัสคุณอยากได้ยังไงอยากให้ติวสอบหรือว่าผมจะไป complex ไปเรื่อยๆเลยหรือว่ายังไงก็แล้วแต่คุณนะครับโอเคมาก็okay we arrive at the last problem of this chapter okay the partial differential equation and this is the most difficult problem actually I hope that you have some background about Fourier series okay which is a chapter in the in the, I don't know how to say, the context of Fourier analysis, okay, which consists of the Fourier series, Fourier integral, and Fourier transform, right? I hope that you get used to the Fourier series. Okay. This is taken from book number 1 and book number 2. We are gonna find uxt in equation number 1. Okay. Equation number 1 has been ขออนุญาตลบไม่ใช่ลบเปลี่ยนเพื่อเปิดไฟล์ของ partial differential equation. Okay. We still have remaining unsolved problem, which is this one, right? The heat equation. And I think this is quite important for those who study, I would say, mechanical engineering or chemical engineering or industrial engineering or any kind of those engineering who may need the heat transfer and so on, okay, in the equation number 1. And yes, once you have seen this problem, right? It's the mixed. Okay, we arrive at the combine. Okay, the title is different. Combine first order and second order partial differential equation, which is this one. Okay, equation number 1. You can see here that this is the first I would say first order differential equation, first order derivative, and in the second, on the right hand side, you have second order derivative, right? This is the combination of the first order derivative and the second order derivative. And you know from the theory that this one belongs to the parabolic or elliptic case. I cannot remember exactly. It's parabolic case, okay, because b squared minus 4ac equal to 0. So two roots will be the same, okay, will be the same root, and it's the real value, okay, it's not complex value, it's the real value. And something more, nothing more, right? Because you can see that here the coefficient in front of the second order derivative with respect to x is c squared. Okay, you can say that the coefficient a is c squared, but there is no coefficient for the cross term x and y. b, okay, b is 0, and coefficient of the derivative with respect to y, okay, we don't or t, okay, but this is the only the first order. But what we define in equation 111 is the coefficient in front of the second order derivative with respect to y or t, but we don't have that. So c is 0, a is z squared, the capital C is 0, 0 times this one will be 0, and b squared, okay, because b is 0, 0 minus 0 will be equal to 0. So this equation belongs to the case of parabolic situation like this, okay, and it's the problem of one-dimensional or 1D heat equation, okay. This equation talks about how the heat propagates from the original point when x is 0, and the heat is transferred with respect to time, okay, because we have the variable time here, okay. U is the heat, the temperature at the temperature at distance x, okay, apart from measured from the original location of the source or the heat source, and the temperature depends on time, okay, and temperature depending on the x location and time will satisfy this equation, and that's why it's called one-dimensional heat equation. Okay, let's move to our actual problem. We are going to solve this equation with some boundary conditions, okay, with few boundary conditions in because the initial condition is that when the time is 0, okay, at starting time we assume that, okay,ครับที่พระพรพิมพ์ชื่อมาครับ and the next one is the heat at time 0, okay, the initial state or the first time that we observe will depends on the function x. Okay, we'll have the heat or the temperature as a function f, okay. The heat may not be the temperature may not be 0, may not remain 0 at all at the beginning, because your metal bar may locate in any room temperature, and that's why they may have the initial temperature right here. And x will start from 0 to capital L. Capital L is the length of the bar or the rod, okay. Oh, to comma stupid ขออภัยนะครับผมพิมพ์2 ครั้งเฉยเลยแม่มาได้ไงpartial derivative แป๊บนึงนะครับพิมพ์ผิดด้วยไม่ได้บอกด้วยนะว่า L คืออะไรนะครับ partial differential equation นะครับเป็นการสอนครั้งแรกนะครับเชื่อจะมีอย่างเงี้ยนะครับมีพิมพ์ผิดพิมพ์ตกครับเพราะว่ายังไม่ได้ตรวจทานละเอียดเท่าไหร่ครับแต่ถ้าสอนหลายๆปีแล้วก็จะไม่มีแล้วเพราะว่าผ่านตาหลายรอบนะครับนี่ยังมี error อยู่นะครับor give a function y oh or given function ผมก็งงว่าทำไมมี2 คอมมาครับคอมมาหลังรับและเบลนะ sorry for that okay and L, right, I need to say what L is whereแป๊บนึงนะครับกำลังแก้อันนี้ให้นะครับ where begin right เดี๋ยวคุณยังงงนะว่า the length of solid bar right แล้วก็ต้องส่งเลยนะเนื่องจากรันหลายอย่างครับคอมจะช้านะครับ okay single comma okay send it to all right ครับมานะอ้าวแล้วทำไมไม่โชว์ว่าเข้ามาที่ไหนครับก็จะไปทราบได้ไหมทำไมเขาไม่แจ้งว่าlecture 211 and partial differential equation อ้าวแล้วคุณไม่แจ้งผมจะทำอย่างไรนี่อ้าวไม่ส่งมาโอ้ไม่ก็ส่งให้อีกรอบก็ได้ครับส่งให้คุณด้วยครับ67หรือต้องรีสตาร์ท iPad ครับส่งไฟล์แล้วไม่เซนซิทีฟไม่รับนะครับต้องส่งแบบรุ่นเก่า6 7 I don't understand why KR มาแล้วนะครับส่งมาที่นี่ครับส่งให้คุณครับก็ผมก็โอ้โหลดช้าเลย70เมกKN save it save it to the Thai yes to this one set okay and we are gonna open any version here this one and we will say that version 2เยอะเกินละ this is for today 02.08.2022 this B01 โอเคhere นะครับขออนุญาตแก้นิดนึงขออภัยนะครับเดี๋ยวคุณผมไม่ชอบอะไรที่มันผิดพลาดนะครับติดขัดนะครับ okay right here and yes L is the length of a solid bar and the next boundary condition is that at the initial condition when x is 0 okay at the left I would say we need to draw okay you have a heat source like this นะถ้าไม่วาดรูปก็เข้าใจยากนะครับ heat source okay and you have a metal rod like this okay and let's say for example you have a distance x like this okay x at this location and you have the clock okay we observe this situation under the time right time t and here this location is called uxt okay you measure the distance from the origin okay and the whole length there the whole length here is L okay the whole length of the rod is L and here is x is equal to 0 okay and here this location is x is equal to L right okay the initial conditions in equation 152a is that the temperature at this location okay at any time will be 0. Okay, and maybe I did not write it properly ผมอาจจะวาดไม่ถูกต้องเท่าไหร่นะถ้าเป็นแบบนี้นะครับ okay so I'm gonna remove it ถ้าผมวาดอย่างนี้ก็ไม่น่าถูกครับเพราะว่าเขาเอาขอบเป็น0เสมออย่างนี้นะครับ okay it's not correct okay it's the rod and here you have a source okay this is the heat source and yeah there you have at x is equal to 0, right? And yeah, this location I would say u 0 t is 0 this end, right? U L T for L will be 0. Okay, it means the temperature at the end here at both ends will remain 0 for whatever time. Okay, for whatever time you observe will be 0 when t is greater than 0. All right, those are the boundary conditions. Okay, we have 3 boundary conditions actually. In the whole rod when t is 0, okay, at the beginning state, there is no heat at all. There is no temperature at all. Okay, but at both ends, the temperatures are fixed to be 0, like this. Okay, this is the boundary condition. Actually, it's like it looks like the initial condition that you have seen before. Okay, the way to solve this equation for uxt, okay, you can see that u will depend on x and t. Okay, it depends on the location x and depends on the time t, what time you observe. Okay, because the temperature changes with time. Okay, let the solution uxt be separated into 2 functions. The first function is g1, okay, and the second function is g2. Okay, we separate it into 2 components. Okay, the first one depends on only x, the second one depends on only t. Okay, there are many ways to solve this equation, but this is one of the easiest way. Okay, we assume that the function is decoupled, is separated into 2 functions. Okay, g1, g2 are non-zero functions that will be determined later. Okay, we are gonna find g1 and g2 later, and let's say g2 is EA. Okay, A is the constant. Okay, and E exponential of lambda t. And lambda is a constant too. We're gonna find lambda later. And this one should not be equal to 0. So we can imply that A is not equal to 0. So let's go further. At both ends, f0, when x is 0, f0 is 0. When f is L, we have also 0 according to this condition. Okay, for whatever t when L is 0, when x is equal to L, when L is 0. Okay, and here this is the original problem, right? But once you have the G1 and G2, okay, as the product here, okay, you can substitute this one into this the original problem. Okay, let's say we're gonna solve by hand. Right here ก็เปิดหน้าครับ I don't know yeah stupid again โอเคตั้งใจจะเปิดหน้าตรงนี้นะครับแต่ว่ามันก็มาขึ้นตรงนี้ให้ครับผมงงผมใช้ good notes ไม่เป็นครับโอเคyes of course u xt is decoupled is separated into g1x g2t all right like this and we will substitute this function into the original problem. Let's have a look at the first derivative curl by curl t, right, of u x comma t. You can see here that curl by curl t of g 1x, right, and g 2t โอ้ขออภัยนะครับผมขออนุญาตเข้าห้องน้ำนิดนึงครับปวดฉี่นะครับไม่ทราบว่ามีคนจะเข้าที่ซูมหรือเปล่าเห็นมีนพดลพิมพ์มาที่ YouTube ครับเดี๋ยวขอเข้าห้องน้ำแป๊บนึงนะครับ Okay, let's get back to our task เขาซ่อมตึกนะครับทำตึกนะครับก็คุณอาจจะมีได้รับเสียงรบกวนบ้างครับทั้งอืดออดอะไรอย่างนี้ครับโอเคก็พยายามจะ ผมก็ควบคุมไม่ได้ครับพยายามจะไม่ให้รบกวนคุณก็ไม่รู้ทำไงครับโอเคjust of course these function will have only variable x, right? So it doesn't depends on t, right? We are going to move g1 out of the derivative. So the next step is that we move g1x out of that, right? And here we still have curl by curl t of g2t, right? Yes, of course, it's not difficult. We have that and also the right hand side here we have the second order derivative of g of u with respect to x. Okay, this is the second order derivative. So we're gonna write curl by curl square by curl x square of u xt, right? And yeah, we just leave it like this, curl x square and g1x g2x, right? And oh sorry, g2 depend on only t, right? Because g2 depends on only t, it doesn't have variable x at all. So we're gonna move, it will be only the constant for us. We will move g2t to the left hand side. Okay, and yeah, we can express it like this, g2t and curl square by curl x square g1x. Okay, and yeah, we have something like that. Then the form of the characteristic equation, or okay, we leave it into, we leave them into the original problem, right? So we have g1x and g2x and g2t like this, g1x and curl by curl t of g2t คุณจะสังเกตนะครับว่าผมใช้วงเล็บตรงนี้นะทำไมอาจารย์ต้องเขียนวงเล็บให้เมื่อยครับเพราะว่าถ้ามีอะไรก็ตามอยู่เศษส่วนนะครับเดี๋ยวมันจะกลายเป็นว่าเอาวันนี้คูณนี้แล้วก็บวกอันนี้นะเป็นเศษส่วนเกินไปนะครับซึ่งไม่ใช่นะอันนี้คือ derivative เฉพาะตรงนี้นะครับหารคันทำเฉพาะตรงนี้โอเคand here is c squared times g2t and curl square by curl x square g1x and of course we remove this one to the left hand side in order to get only the same kind of variable t, and we will move also this one g1x, okay, to this side so that we have only the variable x on the right hand side. We will have variable t only on the left hand side. So once you move them, you get curl by curl t g2t divided by g2t นะคนที่พยายามแก้นี่ก็ช่างคิดจริงๆครับไม่ใช่ผมแน่นอนครับโอเคไหมผมไม่ได้เก่งเนี่ยขนาดนี้ครับ curl by curl x square g1x divided by g1x, okay, like this. You can see right now, oh, I forget to write down the constant c square. Okay, you can leave c square here or c square there, doesn't matter. Okay, they leave the c square right like this. Okay, and the next step is that okay, because we can observe that this one, the right hand side has the variable x, okay, depends on variable x. The left hand side depends on variable t, and you have anything that depends on t, you have anything that depends on x, it's gonna be So it doesn't depend. It has no effect to variable t and x at all, and it means that both quantities should be equal to 0. It should be equal to a constant. Okay, these ratios should be only a constant, and so it should be a constant. Yeah, both should be should นะครับคุณจะได้ยินเสียงเขาซ่อมอะไรกันไม่ทราบนะเมื่อวานนี้ก็ยังไม่มี It should be a constant. So what kind of constant do you think นะครับคิดว่ามันจะต้องเป็นค่าคงที่ประเภทไหน because the constant can be classified into 3 different cases, right? When you say something about constant, the constant can be a positive quantity, positive number. The next one is negative. Oh, I see. 0. The next case is negative number. So what type of number do you think this one is valid? คิดว่าค่าคงที่มันควรจะเป็นครับคุณคิดว่าค่าคงที่มันควรจะเป็นอะไรก็ถ้าเราไม่รู้นะครับคนแรกนะคนที่พยายามแก้นะครับผมว่าเขาก็ต้องลองผิดลองถูกนะว่ามันอาจจะเป็นทั้ง3เคสก็ได้นะเนาะตามสมมติฐานของนักวิทยาศาสตร์ครับถ้าเป็นไปได้3กรณีแล้วเราไม่รู้อะไรล่วงหน้านะครับเราก็ต้องเดินไป3ทางนี้โอเค now let's go ahead with the positive case when the constant is a positive number, right? Let's say I don't know what do they use. Say 0208. This one. Okay. There are 3 cases, right? Positive or negative. Right. Positive, negative, and 0. We consider the positive case right now. I don't know what value do they use. This is the 0 case. Okay. A positive constant, let's say it's omega square. Okay. If omega is a number of real data, one would say whether real or positive real or negative real. Okay. 1, 1. One we can get a positive omega square. Okay. For example, if your omega is -6 square is positive 16. Okay. If your omega is 3, this is number 9. Okay, but it's still positive. Okay. This is the positive omega. Okay, and let's consider if this one is positive number curl by curl t. Curl by curl t of d2 t divided by c square d2t equal to curl by curl square curl x square d2x divided by g1x d2t. This one is g1. I'm stupid. And here is equal to, here is the equality with omega square. Okay. What about the first relation? And what about the second relation? Here is second relation. Okay. The first relation in the first relation we have curl by curl t g2t divided by c square g2t equal to omega square, right? So how could we solve g2t from this problem? What is g? Oh my god. g2t. What is that? g 2t หาได้ไงครับอย่างนี้เรียนมาแล้วนะครับจากบทก่อนหน้านี้นะ partial differential equation ก็คุณสมัยคุณไม่ได้ผ่านบทที่11เนาะแต่ว่าน่าจะมีประสบการณ์แล้วนะครับhow could we find g2t in this case? You can find it. Oh my god. Teacher, the way to find g2t is that you just move, right? Just move this term to the right hand side. Okay, and you will get curl by curl t g2t equal to omega square and c squared d to t. And how could we solve d to t from this problem? จะหาได้ไง d2 d to t was that? You don't have to worry about g to t. Just find g1x. Okay, g1x. Just consider the second relation. In the second relation, we have curve curve square by curve x square g2 g1x g1x equal to, okay, this is also g1x omega square, right? Yeah, we have this relation. In order to solve, again, the same way, just move this one to the right hand side. So we will get curve square curve x square g1x equal to omega square g1x. And we're gonna find g1x right here. How could we do that? Okay, we would let the solution อันนี้ทำไงครับเคยถามแล้วยังไงครับทำไงครับข้อนี้เคยทำมาแล้วอนุพันธ์อันดับ2เนาะนะครับ The way to solve is that you let the solution be y a exponential lambda x like this, right? Yes. Okay. And okay, it's not y, it's g. g1x like this. Okay, and of course the second order derivative of g1x will be yes, of course it's derivative here a in front of that because a is only the constant curve x square of exponential lambda x like this. Okay, and you're gonna get a and lambda square, right? ใครดิฟอันนี้ไม่เป็นครับว่าได้ lambda กำลังสองอียกกำลังทำได้บอกครับโอเคป่ะถ้าดิฟไม่เป็นจะทำให้ดูครับแต่มันพื้นฐานมากนะโอเคป่ะyou just differentiate this term with respect to this variable, the variable x. You would have lambda square in front of that, and after that you substitute back to this thing. Okay, let's manipulate a little bit. This is actually lambda square a E lambda x. Right? And once you substitute into substitute this one into this equation, you're gonna get lambda square a exponential lambda x equal to the right hand side here, omega square g1, okay, which is omega square and a exponential lambda x. Okay, that's a typical term for g1. And of course, we can cancel this equality for AE lambda x, right? You're gonna get you can cancel. Okay, you get lambda square equal to omega square or W square. So your lambda will be it can be lambda 1 will be positive or negative. Okay, negative omega. Lambda 2 will be positive omega like this. Oh no, without square. Okay, omega like that. Is that correct? Yeah. Minus and plus, then of course you would have two solutions for g1x, okay, because we assume that it's a exponential lambda x. So g1x because g1x has two solutions, two characteristic g1x, two characteristic roots. G1x will be a1 exponential lambda 1 and x plus a2 exponential lambda 2 and x, right? So a1 is a constant. Lambda 1 is minus omega x plus a2 exponential omega x like this. Okay, well, this is g1x. Okay, we have solved that already. Then what they provide is what they provide are the boundary conditions, right? When x is 0 and x is 0, it should remain 0. Okay, when x is L, x is L is equal to L or 0, it means that this location. Okay, when x is 0, we have this n. When x is L, we have this n. So u will be 0. So it means g1x will be 0. Also 0. So you would get g1 L, and you get a1 exponential lambda 1 lambda lambda 1 is omega L plus a2 exponential omega L2, right? And the next one when x is 0, g2x, let's see, 1x will also be 0. All right, it means g1 0 will be x a1 exponent minus omega when x is 0, so we have 0 here, and plus the second term exponential of plus omega, and when x is 0 we have also 0 there, and you have okay, this term should be 0, and also this term, right, which is a1 plus a2 this one should also be 0, right? So in order to solve these two conditions, what should a1 and a2 be? We have two conditions. a1 exponential of minus and plus exponential of omega L equal to 0, and a1 plus a2 equal to 0. So what should a1 and a2 be? What should a1 and a2 be? ลองแก้นะครับ แก้สมการอันนี้นะครับ This is the first equation, the second equation. Okay, you can try to solve this one, a1 a2 from this equation, and what should a1 and a2 be? ลองแก้ดูนะครับว่ามันจะต้องออกมาเท่าไหร่ a1 a2 จากสมการ1 2อันนี้นะครับโอ้คนคิดหาคำตอบของเว็บ equation คนแรกนะครับวันดีนี่เก่งมากนะครับ ด้วยความที่มันยากครับเอามาไว้สุดท้ายของบทนี้นะโอเค how could we solve these two equations?แก้ไงครับสมการนี้1 2หา a1 a2 ครับ you can solve this one. Okay, for example, a1 is equal to minus a2, right? From equation number 2, we get this. We're going to substitute this. Equation number 3 into 1. Okay, yes, of course, you would get minus A2 exponential omega L plus A2 exponential omega L equal to 0. So what should L2 be in this equation? A2 ต้องเป็นอย่างไร What should A2 be in this scenario? You just move the common term, right? Which is the A2, and here you have minus or negative exponential negative omega L plus exponential omega L equal to 0, like this, right? Because this is always positive. In order to be 0, this one is not 0, right? It's not 0, but this term should be 0. Okay, it means that we get A2 equal to 0. And once you substitute A equal to 0 into equation number 3, A2 equal to 0 into equation number 3, you would get A1 is equal to minus 0. Right, because A2 is 0 from here. So A1 is also 0. It means your G1x, which is A1 exponential of negative omega x plus A2 exponential omega x, but your A1 and A2 is 0, you're going to get 0 times exponential omega x plus 0 exponential omega x. So the whole term will be 0. Okay. T1x will be 0. So when omega is positive, we cannot use that because G1x will be 0. When G1x is 0, it means when your G1x is 0, uxt will also be 0 for whatever G2t. Okay, so it's trivial solution. Trivial ก็คือว่ามันไม่ได้เกิดประโยชน์ครับ so the porosity constant will give us the trivial solution. Okay, it's trivial solution. We cannot use the positive constant for this case. Let's talk about the next case, 0. K positive number is invalid. Okay, not usable. Next case is 0.ลองทำนะครับลองทำดูนะครับ so you will get G1T G2T มาแล้วครับเจ๊งเกิดการเจ๊งครับต้องปิดใหม่ครับปิดเปิดใหม่ครับ alright okay the ลืมเลยครับว่าผมจะเขียนอะไรตรงนี้ครับเขียนจี้มาเฉยเลย we have to go further and look for now let's try the zero case for the constant okay when if omega is 0 we will get okay we get is that it's curl by curl t right f2t divided by c square f2t equal to curl square by curl x square of f1x divided by f1x right and it's 0 equal to 0 so let's try the second relation with this one okay we will get curl x square f1x equal to 0 times f1x and it's actually 0 okay so what is f1x be in this scenario you can find you cannot find f1x at all so f1x will be 0 or any constant actually okay a constant because if you let f1x be any constant and you differentiate it twice okay it's gonna remain 0 right here we get 0 this general and satisfied condition for the whole set of the solution okay so f1x is a constant okay we cannot do anything when x is 0 when a constant is 0 we get this 0 Okay, this is the case of 0, positive case. Okay. We will try to solve this equation and you find that the root is 0. Okay, let's follow the typical way. You can say the curl square by curl x square ต้องเขียนสีขาวสีเขียวข้อครับ because from here, right, you move this term to 0, you get f1x equal to 0. So what should f1x be? Now, ต้องเป็นอะไร Okay. Because no. I'm stupid. G not F my god I'm stupid ใช้ F มาตลอดเลยมันต้องเป็น G ไม่มีใครทวงด้วยนะครับโอ้ my god ผิดกันยาวๆนะครับ Okay, it's not G, it's F. It's not F, this is G. Okay. Here is G1x. But because we assume that G1x is the right here. G1x is a exponential of lambda x, right? A exponential lambda x. So you differentiate them twice, you're gonna get lambda square a e this is 2 lambda x equal to 0, right? And this is G1x, which is not 0. So this one should be equal to 0. So it means that your lambda will be 0. Positive or negative 0 will be the same, right? It's 0. So lambda 1 is 0. And lambda 2 so is 0. So yeah, we would get G1x equal to A1 plus exponential lambda, which is 0 and x, plus A2x exponential of lambda, the same lambda is 0 and x, right? So right here, you're gonna get G1x will be A1 plus A2x, okay, like this. G1x and A1, A2 like this. And let's consider the boundary condition ผมเพิ่มหน้ามาที่เราไม่ต้องการใช้นะครับผมลองลบดูนะครับจะลบผิดหรือเปล่าไม่รู้โอเคได้อยู่นะครับถูกนะ also this page โอเคเรียบร้อยครับokay we consider the boundary condition when x is equal to 0 G1 0 will be A2 plus A2 0 A2 and 0 right which is the A2 oh sorry this is A1 plus 0 right this one is 0 right so it means that we get A1 is 0 so let's consider the next boundary condition when x is L G1 L will be A1 times A2 and L โอเคโหทำเสียงดังนะครับตึกนี้นะครับไม่รู้เข้าไปในไมค์คุณหรือเปล่าครับ and yes of course this term should be equal to 0 right so we get A1 plus A2L equal to 0 but as we know before A1 is 0 right so we get A2L equal to 0 see it means A2 is 0 because L is not 0 right so finally G1x will be A1 plus A2x and here you have 0 plus 0 and x so the whole thing will be 0 okay it means G1x equal to 0 is equal to 0 which is again trivial okay G1x equal to 0 is trivial solution unimportant โอเคเป็นคำตอบที่ไม่มีความจำเป็นไม่สำคัญครับโอเค so we will not use omega the constant as 0 โอเค the last case นะครับแทนกรณีเป็นบวกแล้วเราพบว่า trivial solution เหมือนกัน G1x เป็น0นะครับเมื่อโอเมก้าเป็น0นะครับเราderive มาเรื่อยๆพบว่าG1x เป็น0นะครับเป็น trivial solution หมายความว่า constant ครับ the constant cannot be a positive number the constant cannot be 0 okay should not be now let's consider the last case which is the positive one right let's consider the negative case for the constantโอเคลองทำดูได้ไหมครับ ผมทำให้ดู2กรณีแล้วนะโอเค what about the มีใครเข้าไปซูมเช็คไม่มีครับโอเคมามีแค่ผมเช็คผมมี account หนึ่งไว้สำหรับเช็คเฉยๆนะ okay let's consider the negative case curl by curl t of g2t divided by c squared g2t equal to curl square by curl x squared g1x divided by g1x equal to negative omega square. Okay, we use the same omega. Omega square will be always positive. Okay, let's say omega is the real number, and we have the -1 here in front of this positive quantity. This will be always the negative value. Okay, negative quantity. So let's try to find g1x. We consider, okay, we find g1x from curl x squared g1x equal to minus omega squared g1x. Okay, and okay, you can move this term to the left hand side. You're gonna get curl square by curl x squared g1x plus omega square g1x equal to 0 ผมว่าจะขึ้นบท complex แต่ว่าเขาก่อสร้างอย่างนี้คิดว่าไม่น่าไปต่อแล้วมันรบกวนครับโอเคมาokay, once your g1x be a e lambda x, okay, so curl by curl x g1x will be a curl by curl x of exponential lambda x, right? So this will be lambda x e lambda x, right? And what about curl square curl x square g1x? You're gonna get again a sorry you get lambda a curl by curl x of exponential lambda x, right? And actually it's lambda square a exponential lambda x. And this term, okay, could be substituted by this one, okay, which is lambda square a e lambda x, and this term too, right? A e lambda x plus a e lambda x equal to 0, and we're going to move a e lambda x, which is the common term, right? a e to lambda x, and here we have lambda square plus 1 equal to 0, and lambda will be lambda square will be -1, so lambda could be minus and plus I, right, which is the square root of -1. Okay, so lambda can be separated into two cases. Lambda 1 is -I, and lambda 2 is +I, positive I. เดี๋ยวมันแอดหน้าแล้วมันจะไปมั่วครับต้องซูมกลับก่อน okay. So in this case you will get the solution to be like this. You get when your solution is I would say 0 plus anything, like bi, for example, like this, the solution will be g 1x can be written as AE0x, right? 0 and x, and oh no, we don't have that. We have a here, cosine, as I can remember this stuff. I cannot remember properly. It's the root lambda plus real and right, and oh, it's omega. I'm sorry for that. My God, I'm stupid. This omega, and you should have also here omega square. My God, I'm stupid. Okay, and have also here omega square, and here will be omega square, and here you have omega, right? So just 0 like that. A1 right, and here we would have omega, okay, omega x plus A2 sine omega and x. Okay, it will be something like this, or simply speaking, because this term will be remain number 1, right? Will remain number 1, so we get only that. Oh, แต่งอีกแล้วนะครับ A1 cosine omega x plus A2 อีกแล้วนะครับ ต้องปิดเปิดบลูทูธใหม่แน่นอนครับโอเคหรือไม่ก็รีสตาร์ทเครื่องผมจำวิธีเทคนิคไม่ได้แล้วปิดเปิดบลูทูธใหม่ครับเพราะว่าถูกรบกวนด้วยบลูทูธนะครับแถวนี้อาจจะมีสัญญาณไวเลสเยอะครับก็ถูกรบกวนได้นะครับไม่ใช่ปากกาพังนะครับผมพิสูจน์แล้วนะครับ oh no this is sine omega x. Okay, all right, like this we get finally, and let's try the boundary condition. When x is 0, we're gonna have G10 as A1 cosine omega and 0 like this, and plus A2 and sine omega and 0. Okay, so we will get this is A1, right, and number 1 plus A2, and here is 0 because sine 0 is 0, so the finally we get A1, and this term should be equal to 0 because the both ends, okay, boundary conditions bring us to 0, right? So it means A1 is equal to 0, okay, and when x is L, okay, the length like that, G1L will be because A1 is 0, we don't have to write this term at all, right? We're gonna get A2 psi omega, and here we have L and R. Yes, you're gonna get A2 psi omega L, and this term should be again equal to 0. So A2 psi omega L equal to 0. It means this term should not be 0, but this term should be 0. All right. So let's consider the case when psi omega L is 0. What should it be then? What should the solution be? What should omega be in this case? Omega ต้องเป็นเท่าไหร่ Okay. And as you know from the basic theory in trigonometric function, psi x will be 0 when x is 0 itself, pi, right? 2 pi, 3 pi, and blah blah blah, infinity. But please note that x can be also negative, right? So this term will be, of course, 0 will be the 0. Minus and plus, minus and plus, minus and plus. So x, sorry for that. X then n, right? N pi. N is a member of 0, minus, plus 1, minus, plus 2, blah, blah, blah. Okay, like this. All right. Yeah, we have it like that. And sorry for that. Yeah, it's all right. So in order to find omega, we will be the same, right? For psi omega L equal to 0, we would get omega L equal to also n pi, right? When n is a member of 0, minus, plus 1, minus, plus 2, blah, blah, blah. All right. Okay. But we want only omega. You have to move out to that location. So omega will be n pi by L, right? Multiple when n again still 0, minus, and plus 1, or we can say infinity, and then minus 1, and then 0, and then 1, and then blah blah blah. Okay. Yeah, omega should be n pi by L. Let's check whether I'm correct or not. ถูกไหมครับนี่ ทำไมเขาไปคนละแบบเลย Yeah, correct. Okay, omega is n pi by L like this. And okay, we are almost finished. We almost finished this one. Okay, now let's talk about the G2T. We have got already G1X, right? G2T. Okay, let's talk about G2T. This is G1X. That's G1X. Okay, we have got already the solution G1X. For the negative constant, we get A1 is 0, right? A2 is not 0, so we get G2X as the G2X as the A2 psi omega X, right? Omega X when your omega is something like n pi by L, and n is blah 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 minus infinity, and minus 2, minus 1, 0, number 1 and 2, blah 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 blah. Okay, now let's talk about G1T. Let us find G1T. Okay, we can find G1T from we can find G1T from curl by curl curl by curl T, right? G1 G2T, I'm sorry for that. G1X, G2T. Stupid. G2T divided by C square and T2T equal to minus omega square, right? Because we are considering the negative constant case right here. So you move the denominator to the right hand side. Again, to the right hand side. You get curl by curl T, G2T equal to minus omega square and C square and G2T. And we are going to need a solution for G2T, right? So we have you can express it like we move these terms to the left hand side. Curl by curl T, G2T, and plus omega square C square G2T equal to 0. All right, and again we assume that G2T is A E lambda T. Okay, and this term will be lambda, right? This term will be after you differentiate, right? Okay ผมดิฟให้ก็ได้ curl by curl t of g2t will be curl by curl t a e lambda t. So you're gonna get lambda a e lambda t, right? So on the left hand side, we substitute this one to the left hand side of this equation. You're gonna get lambda a e lambda t plus omega square c square lambda. Oh no, there is no lambda at all. This term a e lambda t equal to 0. And now we just move the common term out of this summation. A e lambda t is the common term, so we have lambda plus omega square c square equals 0. This term is the solution itself, right? This is the g2t, and g2t should not be 0, otherwise it's going to be trivial solution. g2t should not be 0. And this term should be 0 because the product of this term should be 0. This term should be 0, right? So it means the lambda plus, oh no, lambda plus omega square c square will be 0. ผมเนี่ยไม่ซูมแล้วมันก็จะหลุดไปข้างล่างครับ Okay, it means the lambda is minus omega square c square. Oh, sorry. We substitute lambda back to this one, right? You will get g2t as a e lambda is this term, so omega square c square and t. Okay, so from the general solution, from the separable solution, uxt is g1x g2t, right? And as you know, g1x is this one. g1x is this one. What is that? g1x is not g2x. g1x is this one. a2 sine omega x, a2 sine omega x. What about g2t? g2t is this term, okay, which is a only, exponential minus omega square c square and t. All right, so what could we do then? We have to get rid of something, right, by using the boundary condition that this problem has provided before. นี่ผมถอดหูฟังนะก็มีเสียงเบาลงครับเสียงที่เขาแบบขุดเจาะคอนกรีตครับ What should they do then? ทำไมมีทั้งคอร์ดและไซน์ก็ในเมื่อมันหายไปแล้ว Okay, A1 is 0. We have only A2. Okay, we have this. Yeah, AA2 sine omega x. And we will consider the case, the boundary condition in 152b. Okay, let's open another page. We go to the boundary condition. This one. 152b. What is 152b? Okay, 152b means the ULT is equal to 0. So for whatever time t, okay, at this end when x is L, the temperature should be 0. Okay, so we go ahead with that. Okay, when we consider the case when x is we consider the case when x is L for whatever time t, okay, for any t. Okay, we're gonna see that when x is L, we have ux when x is L. For the whatever t, we have A2 sine omega and L A E minus omega c squared and t. All right. And yeah, omega L. And this will be equal to 0, right? Yeah. This will be equal to 0. You can see that any term can be 0, but except for sine omega L. Sine omega L will be 0. Because this cannot be 0, this cannot be 0, this cannot be also 0. And we are going to get omega in pi by L, right? For n is in between 0 minus plus 1 minus plus 2 blah blah blah. Okay. Yeah, we get omega from this condition. ก็เหมือนเดิมไม่มีอะไรมาทำไม and now we will manipulate all of that. Okay, we will substitute n pi by L to omega. Okay, because omega is something like that. And let's see what will happen. Omega is this term, right? We're going to substitute omega to this location. So uxt will be A2 sine omega. Omega is not omega because we're going to say n pi by L and x, right? And exponent, is just A. and exponential minus omega, right? So this one will be n square pi by L square and c square t, right? C square and t like this. And we can combine the constant. Let's say it's called B2, okay, and you have psi n pi, okay, let's say it like this, n pi by L, and x, okay, for simplicity, and exponential pi minus pi square L square n square c square without t square. T is a single without square. Okay, what else? Because this is valid for only n, right? You can say this is the solution with subscript n for only n. N can be from 0, minus 1, plus 1, blah, 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 right? Now let's consider the entire solution, the solution that covers every case here. Okay, let's say this is n, and here B2n, okay, R. Now let us consider the entire solution. The solution that cover that cover all n from 0, minus, plus 1, minus, plus 2, blah, blah, blah. Okay, and go to next page. Okay, so u xt will be summation n. Yeah, you can see it. There will be sorry, there will be 3 terms. The first term is from minus 1 until minus infinity of u n xt, and plus the second term when n is 0, we're gonna have u0 xt, and the last term is the case when n is positive, n from 1 until infinity plus infinity, and this is un x and t. Okay, what about this term? Okay, u0 xt mean you can say it, this is b2 or without 2 at all. Okay, just say it's b that depends on only n. Okay, b0, we would say this is b0. b0 in psi n pi l by x, n pi by l times x, and exponential negative pi square. Oh, I'm sorry for that. L should be also square here. Oh, ผมก็เขียน2แล้ว L square, n square c square t. All right. Oh, when n is 0, I'm sorry for that. So this term should be 0. You know, a 0 squared times anything will have no impact. Right? This will be 0, exponential of 0. Oh, sorry, this term should also be 0, right? Right. Okay, let me summarize. This is actually equal to 1, right? This is actually equal to 0. So 0 times B0 times number 1, this term will be 0, right? This, okay, the first one here นะผมแยกคิดให้คุณดูง่ายๆครับทีละก้อนทีละก้อนนะ okay, this term we move it to be here. All right, so let's talk about the negative term here. Let's talk about the negative term ก่อนที่จะพูดถึงเทอมติดลบครับผมขออยากเข้าครับแป๊บนึงครับปวดฉี่ครับ exponential summation from -1 until infinity of un xt what is that then ขออยากเข้าห้องน้ำแป๊บนึงครับเดี๋ยวมาดีไลฟ์ต่อให้ครับ Okay, we are back to derive the negative term here. Okay, when n start from negative, right, we are gonna get b with subscript -1, right? U and here psi of minus pi by L and x, right? And here we're gonna get exponential minus pi square L square and minus 1 square, right? C square T, right? And plus the second term, which is minus 2, right? Sine and minus 2 pi L times x, and exponential pi square L square minus 2 square C square and T, right? And plus blah blah blah. Okay, until negative infinity. Okay, the important thing is this term, right? It's negative 1, right? Because psi x, because you know that psi minus x is the negative value of psi of positive x, right? Yeah, we are gonna apply this rule to this term. Okay, so means the negative term n from minus 1 until infinity un xt will be minus b minus 1 of psi pi by L, right? And x exponential. This one has nothing to do. Okay, because the square of negative value will be always positive. Minus pi square L square and number 1, right? C square and T. And then the next term is minus b minus 2 psi 2 pi L, right? 2 pi by L, sorry. X exponential of pi square L square minus and no. And here 2 square C square T and minus blah blah blah, right? So let's talk about the positive term. We consider now the positive term. Positive term means the summation starts from number 1 until infinity of the same thing, un xt, and that's equal to b1 psi n pi L by x, so is number 1, right? Pi by L times x exponential minus pi square by L square n, right, which is number 1, C square T. Oh, I have to open the next page. And the next one will be plus b2 psi 2 pi L x exponential negative pi square by L square, and next term is 2 square C square and T. Please note that this will be the same, right? Yeah, the same. And the next term is plus blah blah blah, right? The zero term here has nothing to worry because has nothing that we need to worry because it's 0. Okay, this term is 0, and this term we have only these two terms, right? Please note that the negative term and the positive term are nearly the same, right? And once we write the entire solution, we're gonna get some ผมชอบเขียนช่วยๆนะเดี๋ยวคนดูไม่รู้เรื่อง okay we would have b1 minus b minus 1, right? minus b minus 1. Okay, and now psi pi, pi by l x exponent minus pi square by l square and c square t. Our next term is this one, right? Minus b minus 2 and b2, so plus b2 minus b minus 2 and psi pi by 2 pi by lx, okay, and exponent negative pi square l square is 2 square c square t, right? And plus blah blah blah, the next term, right? So if we define these two constant, let's say it's c1, let's say this is c2, so we're gonna get at the end summation n from 1 until infinity of c with subscript n of psi n pi by lx, n pi by lx, an exponential of minus pi square by l square times n square c square t, right? Yeah, that's the final solution, I think. ก็มาถึงคำตอบสุดท้ายจนได้ Let's check whether our final solution is correct or not. ดูนะครับว่าถูกไหมครับพาคุณมั่วมาเรื่อยๆ Yeah, here we get c n psi n pi l by n pi by l x exponential of n square c square pi square by l square t. Yeah, that's correct. Okay, ถูกต้องแล้วนะครับ โอเคถูกแล้วนะครับ so let's consider the next thing, which is almost the thing. Okay, it's the story about boundary conditions, because as we have seen before, the last topic in this chapter is boundary conditions, okay, which is one. The last topic of this chapter is boundary conditions. This is boundary conditions, okay. The first person we need to get used to is Dirichlet. Okay, you may have seen or heard his name Dirichlet before in the chapter about Fourier series or something like that. Peter Gustav, I don't know, Dirichlet. I don't know how to Lejoyner Dirichlet. Okay, if this is pronounced in no, Lejoyner. Yes, Lejoyner Dirichlet. Okay, if this is pronounced in a German way, he was a German mathematician who made deep contributions to number theory of Fourier series, and other topics in mathematical analysis. Okay, Dirichlet. The next person is Neumann. Okay, Karl Gottfried Neumann. He was a German mathematician too, who worked on the Dirichlet principle. Okay, work on this person. I think this professor is still alive. Or sorry, just passed away a few years ago ครับคิดว่าน่าจะเพิ่งไม่เสียชีวิตแล้วนะ1859ครับมีอายุแค่54ปีเองคนนี้ Okay, he was a professor worked on the Dirichlet principle, the work from this person and the integral equation. And of course, this person is the one you have seen before. He is Baron Augustin Louis Cauchy. Okay, Cauchy was a French mathematician, engineer, and physicist who made pioneering contribution to several branches of mathematics, including mathematical analysis and continuum mechanics. Okay, these three persons will serve as the basic name for the boundary conditions. There are three common types of the boundary conditions that can happen to the partial differential equation. As you know, you have seen before, there are boundary conditions, right? The first one is Dirichlet's condition. The value of u of theta is specified at each point of the boundaries. Okay, that's what you have seen at the end of the rod. We have 0 temperature, okay, 0 degrees, 0 Fahrenheit, oh no, 0 degrees Celsius. Theta is the vector that contains all variables of the function u that depend on. And Neumann condition is a little bit more complicated. It's the condition about the normal derivative. Okay, what is normal derivative? It's related to what you have seen before in EE111. Okay, it's derivative of u of theta with respect to n. N is the a normal vector, but normal vector that is united is called un. Okay, and you just differentiate that function and dot product to the unit normal vector. Okay, and the next condition is Cauchy condition. Okay, u theta and both the normal derivative and the value of u theta are known or specified at each point of the boundary. And these are the boundary conditions that can happen in partial differential equations. Okay, we finished the fifth chapter, partial differential equation, and we're gonna open or continue to the next chapter, which is the complex variable นะครับก็ไปบทต่อไปเลยนะหรือว่าคุณจะพอเท่านี้นะครับเดี๋ยวเขาจะหาว่าสอนไม่ครบไม่อะไรนะครับ sixth where is that I didn't throw it away to thisถ้าจะเอามาทั้งอันนี้ผมต้องรีสตาร์ทครับเซฟครับ I may need to save this one นะครับขอโหลดนิดนึงครับเพื่อเอาลงเครื่องครับยังไม่ได้เอาลงไว้ในเครื่องบทที่6นะครับบทที่6ยังเตรียมสไลด์ให้ไม่หมดครับสอนเท่าที่เตรียมสไลด์ได้ครับก็คือน่าถึงแค่ complex function ง่ายๆครับอันนี้ง่ายกว่า PDE เยอะนะครับเราทำไงโอ้มันโยนไม่ได้ครับผมต้องรีสตาร์ทเครื่องครับเขาไม่โยนไม่ได้เดี๋ยวลองโยนให้อีกรอบก็ได้ครับโยนไฟล์มาไม่ได้ครับขออนุญาตรีสตาร์ทเครื่องครับ I need to quit the Zoom right now at the moment นะครับขออนุญาตรีสตาร์ทเครื่องแป๊บนึง to this person and we're gonna restart this machine. Okay. All right, we turn on. โอเค all right and like this okay, I have to throw away this one yes to the Thai to my iPad to เนี่ยพอรีสตาร์ทแล้วแจ๋วเลย EE211 yeah session fetish and iPad lecture 211 where is the 6 yeah okay yeah all right บทนี้ง่ายครับ เหมือนม.4 คุณ แต่ว่าแค่ช่วงแรกๆนะมันจะง่ายนะ 6 okay and I have to close this one too remove this one okay remove that then เดี๋ยวอัปโหลดอันนี้ไฟล์นี้ให้นะก็อัปโหลดไฟล์นี้ให้นะ EE211 yes โอ้ไม่ให้ไปแล้วไปแล้วalright ไม่ให้ไปกำลังไปแล้วโอ้ผมต้องโยนไฟล์คุณก่อนนะเดี๋ยวคุณไม่มีไฟล์ดูระหว่างที่เรียนลืมไปเลยนะ complex plane ไปแล้วนะของโอเค fifth ปิดนะครับขึ้นบทที่ 6 แล้วนะ the 6th chapter complex okay complex plane complex function and analytic function โอเคแล้วผมงงว่าทำไมยังเป็นจุลาย19อยู่นี่ด้วยวันทำไมผมไปคิดว่าจะขึ้นที่19นะแต่ว่าไม่ใช่ครับจริงขึ้นวันนี้ครับก็คือวันที่2 สิงหาคมนะครับโอเคไหมไฟล์ขึ้นเป็นจุลาย19เฉยเลยมาก่อน stupid okay the content of this chapter is the following we will introduce something okay which is what you have already seen you are in the second year junior or something like that you would have seen the complex number quite a lot right the next one is complex plane as the chapter title suggests complex plane the next one is complex function okay right is complex function and analytic function which is the spatial type of the complex function but the slide for this is not finished yet we will complete all these 3 sections okay นะครับไปแค่เท่าที่สไลด์มีตอนนี้นะเดี๋ยวผมไปเตรียมเพิ่มให้ครับอันนี้ง่ายมากครับบทนี้ หลับตาคุณรู้เรื่องแน่นอนครับ Okay, let's talk about the introduction to complex number. For example, we have the second polynomial, okay, second order polynomial like z squared plus 1. What is the set, the solution to this one? Okay, in many situations, for example, this one, okay, z squared plus 1, we cannot find the solution easily in real way. And also this term z squared minus z plus 4, okay, we cannot find the real value solution. So it is necessary to introduce the complex number. Okay, for example, if you want to solve 1a, okay, z squared plus 1 equal to 0, it means you have z squared equal to minus 1, right? And z will be minus and plus square root of minus 1, right? And that's minus then plus I. All right. And what about z squared minus z plus 4 equal to 0? What should that be then? You can see that the way to solve this one has to do with the formula, right? Minus b minus and plus square root of b squared minus 4ac, right? Divided by 2a, right? And you get z equal to minus 1, right? And divided by minus and plus square root of minus 1 square and minus 4 1 minus 1 minus and plus square root of 1 minus 16 divided by 2, and you would get somehow 1 minus 10 plus I square root 15 divided by 2. All right, and that's the way we solve it by using the complex number, right? Well, let's talk about the history of the complex number. Girolamo Cardano. Okay, I don't know how could we pronounce his name. Pronunciation, right? Girolamo Cardano. Okay, here, Girolamo Cardano. I don't know why they use, sometimes they use E, sometimes they use I. Anyway, let's try.อยู่ YouTube จะได้ยินไหมครับดิคุณเปิด YouTube ดูเลยนะครับอันนี้นะครับ Gerolamo Cardano Cardano. That's the way to pronounce of this person. Okay, Gerolamo Cardano was an Italian polymath in a very, very long time. It was around 500-600 years ago. Okay, 500 years ago. Including physician, biologist, physicist, What is the difference between physician and physicist? Physician is the person who try to kill your body, okay, to recover your body in a physical way, right? And physicist is the person who studies something about physics, right? Okay. นะครับป่ะใครอยู่ YouTube ก็เปิดฟังเองเลยนะ how to pronounce คนนี้ครับชื่อคนนี้นะนายกิโลลาโมคาราโนครับก็จะมีวิธีที่ออกเสียงที่ถูกต้องครับโอเคhe was the Italian polymath. Okay, polymath means the person who is great in at anything, at many things. Physicist, chemist, astrologer, okay, astronomer, philosopher, writer, and gambler. Okay, he play also gambling. Okay, okay, the complex number are divided by this person, Girolamo Cardano. And the complex number can be separated into two parts as you have seen จริงๆคุณเรียนวิชา292กับผมมาแล้วมันคล่องแล้วนะแต่ว่าเขาเอา211มาอยู่ในเลเวลเดียวกับ292ซึ่งมันทับซ้อนกันนิดหน่อยนะครับแต่ว่า211มันก็จะไปในรายละเอียดลึกกว่าของ292นะเพราะว่า292ใช้ complex number นิดเดียวนะครับเลขซ้อนนิดเดียวไม่ลึกมากครับสำหรับเฟเซอร์แต่ว่า211ที่จะไปลึกนะถ้าเรามีเวลาก็ไปได้เรื่อยๆครับแต่ว่าจะหมดแล้วครับโอเค the first component is the real part right which is x the imaginary part is y right I is square root of -1 which is the unit imaginary number right the real part operator is re right you take the real part you get you pick up only this component, okay, the x1. The imaginary part is the one after the variable I, okay, pick up only the variable y, and you get y like right here. Okay, and let's move to the next thing. The complex plane follows the Cartesian coordinate system, which has the two perpendicular coordinate axes, such as the horizontal axis. X-axis called the real axis and the vertical y-axis called imaginary axis. Okay, like this. We have a real axis and we have the imaginary axis. This, for example, this is 1. Okay, without I at all. Okay, when we don't have the imaginary component. It stay only on the real line here. This is the real line. And once you have plus I, okay, you go up by 1 along the y-axis on the imaginary axis. And if you have the pure I, okay, without number 1 at all, you just go up, okay, without to go forward, okay. And what about -1 plus I? Okay, you still behind in the positive way of imaginary parts because of the +1 plus I here, but you have to go left along the real line because this is the negative value of the real axis. Okay, what about -1? Okay, -1 has no imaginary part at all. It stay on the real line. You don't have to go up or go down because you don't have the imaginary number here at all. It's -1, but you have to stay at the left side. This is the positive side because it's +1. Okay, let's talk about -1 and -I. Of course, you just go from -1 and you have to go down a little bit by 1 according to -I. Okay, and what about -I? -I will stay on the imaginary axis without any real at all. And what about 1 - I? 1 - I is the combination of +1 and -I. Okay, is below the real axis. Okay, in the negative part of the imaginary axis, and it's positive 1. Okay, like this. Okay, the complex plane is first illustrated by this person, ชงโรเบิร์ตอากังออกเสียงยังไงเพราะไม่เคยเรียนภาษาฝรั่งเศสทุกวันนี้ก็ไม่เคยเรียนครับชอง Robert โอ้อันนี้อธิบายเยอะนะครับอันนี้ไม่ใช่อันนี้ไม่ได้ออกเสียงไม่ได้ออกเสียงแบบภาษาฝรั่งเศสด้วยไม่มีนะไม่มีออกเสียงให้ฟังเอาชองโรแบร์ครับเอาเป็นคำว่าชองโรแบร์แล้วกันชองโรแบร์นะครับชองโรแบร์นะครับชองโรแบร์ตรงนี้นะครับไม่มีคนที่เป็นฝรั่งเศสจริงๆนะครับโอเคไม่เป็นไรมาเอาออกเสียงให้ฟังครับโอเคJean Robert I don't know how to pronounce Argon Jean Robert Argon is noted for publishing the geometrical interpretation of the complex numbers known as Argon diagram okay we use his theorem สิ่งที่คุณเห็นเนี่ยครับเนี่ยระนาบเชิงซ้อนเนี่ยเขาเรียกว่าแต่ก่อนสมัยก่อนเรียกว่า Argon diagram นะครับโอเคไหมก็คือdiagram ของใต้คนนี้โอเค and the complex plane is sometimes called Argon diagram and complex conjugate of the complex number can be written as something like this, right? You have seen before right? In EE211 it's not difficult at all of z equal to x plus iy okay you just change the positive side here to be negative sign okay in front of the unit imaginary number and the important formula related to the complex conjugate involve when z plus when z is added to z complex conjugate it's going to be 2x okay when we divide this one 2x by 2 we're going to get the real part and that's why real z is the half z added to z star or z complex conjugate okay and let's talk about the difference if we subtract the z by z star or complex conjugate it's going to be 2yi right 2yi โอเคเอาตรงนี้นะครับลบนี้นะก็จะเป็น 2yi and if you wanna find y just take the just divide this number by 2 okay and you get the imaginary part okay imaginary part will be 1 by 2i right and z minus z star okay and if you multiply the complex number set by its conjugate like its complex conjugate like z star it's gonna be x squared plus y squared okay and that's the radius okay the radius okay complex number can be expressed also in a polar form as the r exponential of I theta okay and r is cosine theta plus I sine theta and you know this is the Euler identity I don't have to bring you to Euler right because you have seen the face the Euler's face so many times he has one broken eye right นะครับ Euler เสียตาข้างหนึ่งครับเห็นไหมคุณเห็น Euler บ่อยแล้วไม่ต้องเอารูปมาให้ดูแล้วครับ this is the Euler's identity right from exponential I theta And we can say also this is the sixth function. Okay, six means cosine plus I sine. Okay, just take C and I and S. Okay, C and I and S. The first letter here and the second letter here. C, I, S. Okay, and that's why we get the sixth function here. Okay, sixth function is cosine plus I sine. And here is, if you compare it to the original expression, real and imaginary part of the complex number, you would say that this is the real part, and here is the imaginary part, right? Sine theta is imaginary part, cosine theta is real part. Okay, as the relation between the Cartesian coordinate and the polar coordinate is given by x and x as cosine theta, y as sine theta. You can see that absolute offset is square root of x squared plus y squared. And of course, if you distribute it, okay, substitute cosine theta into this one, sine theta into this one, you're gonna get cosine sine, right? And of course, r square, you get r, you can distribute the square to r, so cosine r to square to r square to sine. You get r square, you get cosine square, you get sine square here, right? But from the basic trigonometry identity, cosine square plus sine square will be equal to 1. You get number 1, so here is only r, right? And this is actually the same thing as the Z and Z complex conjugate. Okay, Z and Z complex conjugate is right here. Okay, the next one is y by x. Let's consider the ratio y by x. Y by x is r sine theta, right? Y is r sine, x is r cosine, and we get tan theta. And if we want to find the angle theta, just take the inverse trigonometric function to this one. Okay, so we will get our r as this one. Okay, we can bring the relation this one to this term. Okay, and that's called r equal to square root x squared plus y squared, the relation between the polar coordinate and the Cartesian coordinate. Okay, the next one is, if you want, the next one is the angle theta. If you want to find angle theta, just take the inverse tan function to this one. Okay, theta is arctan y by x, and the whole thing could be seen here on this figure. Z is x plus iy, exponential of I theta, and our Z complex conjugate is r exponential of I theta. And yes, of course, theta is arctan y by x. Okay, the amount here y and the amount here x. Radius, okay, the radius of the modulus is square root of x squared plus y squared, right? It's quite simple, you have seen before. This is the imaginary axis, this is the real axis. Okay, now complex number Z and its complex conjugate Z star. Okay, Z star, it's the red one here in the complex plane. In Cartesian form and in polar form, Z equal to r exponential I theta. Complex function is this one. Okay, complex function is the function that maps complex number to complex numbers, right? In mathematical functionality, functional way, we can say fz is a map between the input z, this one, which is the member of this complex set, to this one, okay, to f complex set, and can be decomposed into its real part. Let's say ui xy. Okay, ui xy is the function that maps two sets of the real value x and y to a single value of real quantity, which is u, and imaginary part v x y. Okay, x and y is x and y are 2 times 1, right? To r, okay, to v. Okay, and f can be decomposed into the real part and imaginary part. Okay, let's talk about an example. Okay, if we want to determine the real part and the imaginary part of the function of fz, z squared plus 3z minus 1 when z is 1 plus I3. So what is u and v in this case, right? There are two ways to solve this problem actually. Okay, the first way is the simplest one. You just substitute it, right? You can see that fz is z squared, right? Plus 3z minus 1. And f of z, which is the when z is when z is 1 plus I3. Okay, we're gonna see that we want to find f1 plus I3 will be 1 plus I3 square. Okay, we substitute z by 1 plus I3, and this is plus 3 z I plus 1 plus I3 and minus 1. Okay, and you get this one, right? Here is 1 square plus 2 1 I3 plus I3 square and plus 3 plus I9 minus 1, right? And the next thing is you have 1 plus I6 minus 9 plus 3 plus I9 and minus 1. Okay, the next thing is that you get 1 and 1 1 and minus 1 can cancel each other, and you get minus 6, right? This one minus 6, and you have here I6 and I9, that's I15. And let's compare it to u plus iv. We can see that u x y is minus 6 and v x y is you can see x is, you can see that here x is 1 and y is 3, right? 1 comma 3 is 15. Okay, and that's it. But there is also another way if you want to find the solution. That way is a little bit that way would require more effort. Okay, f x plus iy equal to iy, not I3, stupid. X plus iy, and here is x plus iy square and plus 3 x plus iy and minus 1. Okay, and here you can distribute it. All right. Here you have is that correct ใช่ไหมครับทำวิธีนี้ป่ะอีกวิธีนึง just yeah you try to manipulate and here is x square plus 2i xy and minus y square plus 3x plus I 3y minus 1, right? And you will get the real component, which is the x square minus y square and minus 1. And you have also another term, which is 3x here. Okay, and we will say this is called u x y. Okay, the next term is plus I of what? I of 2xy plus 3y. Okay, and this term is vxy. All right, vxy, and yeah, because x is equal to 1 and y is equal to 3, right? From z is 1 plus I3, right? So u1 3 will be 1 square minus 3 square minus 1 plus 3 1, and that's 1 minus 9 minus 1 plus 3, and that's again minus 6. And v1 comma 3, what is that then? It is 2x is number 1, y is number 3, and plus 3 y is number 3. So we get 6 plus 9, which is 15. Okay, and yeah, there we go. We have finally u1 3 is minus 6 and v1 3 is 15. Okay, and that's it. Let's check whether both methods are same or not. Yeah, both methods will be the same. Okay, minus 6 15. Yeah, minus 6 and 15. All right. Okay, let's go ahead and we have another example. I will let you do it. Okay นะครับให้คุณลองถามนะครับถ้า fz เป็น i 3z บวกกับ 6z สตาร์นะ6คูณกับ z complex conjugate ยกกำลังสองครับที่ z เท่ากับ1/2บวก 4i i4 นะครับถามว่า uxy และ vxy เป็นเท่าไหร่นะครับช่วยหาให้หน่อยนะครับคนที่อยู่นะครับเชิญครับเดี๋ยวระหว่างนี้ผมแคปเจอร์รูปคุณนะเหลือ12นาทีนะครับให้คุณลองคิดมือเล่นๆครับเดี๋ยวเราก็จะจบกันวันนี้แล้วเดี๋ยวครั้งหน้าคุณเลือกมาครับจะให้ทวนพวกฟูเรียให้หรือว่าจะไปคอมเพล็กซ์ต่อไปเลยก็ได้นะไป analytic function นะผมจะได้เตรียมให้ถูกครับเดี๋ยวแคปเจอร์หน้าจอคุณก่อนครับ สุขภักดิ์มาด้วยนะสุขภักดิ์แซ่หิงได้ไหมครับทำได้ไหมครับอ้าวทิศนะมาด้วยนะครับอีกที่หนึ่งครับโอเค นะครับก็หมดเวลาแล้วนะครับผมทำให้ดูแล้วกันครับไม่มีใครทำเลยโอเคwebsite is somehow so of course z is 1 by 2 minus or plus I4 right it means you have x is 1 by 2 y is number 4 right in f of 1 by 2 plus I4 sorry I4 will be I3 in 1 by 2 plus I4 okay and plus 6 and set complex conjugate of these terms, right? The complex conjugate of this term will be the change of positive side to be negative side, right? So we have 1 by 2 minus I4, right, in square 2, right? And here you would get I in 3 by 2, right? 3 by 2 I, you can say that. And here you have plus I square and 12, right? And here you get 3 minus, oh, no, it's square. So you get 1 by 4 and 2 of these, right? 2 of these will be minus I4 and plus minus I4 square, right? And there you go. It's I 3 by 2 and minus 12 plus 3 1 by 4 minus I4 and here you get minus 16 and closing the parenthesis. Right, and yeah, here we have minus 3 by 2 and minus 12 and plus 3 of the differentiation, the difference between these two terms, 64, right? So it's gonna be minus 63 by 4 being minus I4, right? So you get I3 by 2 and minus 12 and minus 189 by 4 and minus I12 divided by 4 and plus I, right? 3 by 2 and minus 24 by 2, right? You get what's that in 97 12 13 237 by 4 and minus I and 21 by 2. All right, so you are therefore u x is 1 by 2 and 4 is minus 237 by 4 and vxy is minus 21 by 2. All right, let's check whether it's correct or not. One, two, I'm stupid.ผิดนะ 45 not 21 what's the problem มีผิดด้วยนะครับโอเคไหม เกิดอะไรขึ้น I3 set 3 by 2 square minus 12 right I 4 scrap these plus minus 16 minus 16 4 all right yes all right this one is minus I4 in 64 minus 63 minus 12 3 3 by 2 minus 63 by 4 yes and minus I4 minus I12 minus I12 why but they say minus I24 why we have only 3 6 okay that's number 6 I'm stupid my god stupid 6 6 and 6 right it's 3 and 137 and here is 24 not 12 I'm stupid and there we go with constant right 3 7 8 3 7 8 and here we have 48 48 minus 40 huh? and yeah, 886. Oh my god. 1 2 4. Here is 45. It's 45. Four, 2, 6. And that's the minus 213 by 2. And here is the minus 45 by 2. All right. Yeah, that's it. Okay. All right. ถูกต้องแล้วนะครับ Okay. See you on Thursday, right? ครับไม่มีใครทำมานะครับก็จบเพียงนี้นะครับ พบกันวันพฤหัสครับ ก็มีคำถามอื่นใดนะครับ ก็โปรดแจ้งได้นะครับ สวัสดีครับ บ๊ายบายครับ เดี๋ยวอัปโหลดอันนี้ให้นะนี่วันนี้ง่ายนะครับ211ตรง complex นะมันยังไม่ถึงส่วนยากของเขา right okay you have to also send to that computer yeah. That to okay and to this all right ไปแล้วนะโอเคครับบ๊ายบายครับปิด Zoom oh I forget to get into the Zoom meeting my god sorry for that so we have to quit it from here right แต่ว่าดื่นมันยังอัดอยู่นะครับ ลืมเข้าไปใน Zoom นะครับรีสตาร์ทเครื่องครับ These one right TV where is it? And where is the